So the company Snowflake drops their very own large language model, Arctic, the best LLM for enterprise AI, efficiently intelligent, truly open. And this thing is really different from a lot of the other things we've seen for a number of reasons. One, looks like they're really focusing on the B2B space. So this isn't for the end consumer. This is for businesses. The problem that they're trying to solve is this: for big businesses building LLMs for their own internal use or for customer use, but the point is their own custom LLMs. Well, it's very expensive and resource hungry, right? It can cost tens to hundreds of millions of dollars. So that's the problem that they're setting out to solve. So they're launching their own LLM, Arctic, and it excels at enterprise tasks such as SQL generation, coding, and instruction following benchmarks. But it's cost effective to train. More on that in just a second. And it's truly open. Apache 2.0 license provides ungated access to weights and code. So this is kind of important. They're also open sourcing all of their data recipes and research insights. Now, right now, there's kind of a battle going on over open source AI. And Snowflake Arctic is available on Hugging Face, kind of the central place where a lot of people go to work and learn about the various open source AI models. It's, I think, a bigger deal than people realize. That's Sundar Pichai from Google, the CEO of Google. On this side of the table, we got Jensen Huang, founder of NVIDIA, Satya Nadella. Are they just staring at each other from across the table? They're just glaring at each other. That's, of course, Microsoft and Google. And all the other big names were there too. But this is the founder of Hugging Face. And Snowflake has their own cloud service, Microsoft Azure, NVIDIA API, Perplexity, and Replicate's on there too. If you wanted to try the model out, actually on Replicate, it's pretty easy. You don't need to log in or anything else. You can just start messaging it. So the big thing that they're pushing for here is this idea that they're giving you enterprise intelligence for low cost training costs. So compute used for training. So Arctic here is the baseline. So let's say, and we're looking at the best performance over the cost, again, for training. So they're saying that the Llama 3 70 billion model, which of course, as we've seen, is very, very good, surprisingly good, right? But it's 16 times more expensive to train. The other models that they list here, Llama 3, 8 billion, Code Llama, RX, etc., they're more expensive to train and they don't provide as much enterprise intelligence. And enterprise intelligence, so they here kind of have their own formula for it. So they're averaging coding, the scores on the various coding benchmarks, SQL generation, and instruction following. They're seeing specific kind of needs from their enterprise customers, specific use cases. They need LLMs to build conversational SQL data copilots. So from a metrics perspective, they want something that excels at SQL code, complex instruction following, and the ability to produce ground answers. So they capture these ability into a single metric they call enterprise intelligence. So again, everybody kind of has their own metrics. Everyone has their own benchmarks that they try to use. It's usually a good starting point, but you got to test the model for yourself to see how good it is at your specific use cases. But their big claim to fame here is they're saying that for having this top tier enterprise intelligence, as they call it, they do so with a training compute budget of under $2 million. Now, why would we care how much it costs them to train these models? I mean, we wouldn't. The end consumer, if you're using it for your personal task, you don't care how much it cost the company that made it, how much it cost them to train it. But since they're open sourcing it, they're providing their own data recipes, as they call it. What this means is that Snowflake customers and the AI community at large can train their own custom models in a much more affordable way. If I recall correctly, they were saying that GPT-4 costs $60 million to train at the time that it was being trained. Those are not official numbers. I think it was an estimate. And so something like this costs under $2 million to train. And so here they kind of compare the different architectures. So here's Llama 3 70 billion, kind of the recent model that came out of, I don't want to say came out of nowhere, but definitely I think it surprised a lot of people. I think that's definitely fair to say. You have your mixtural models, more and more going to MoE, mixture of experts. So instead of having one big model, it's sort of a clustering of several smaller models. And a lot of them use 8 mixture of experts or 8 experts to create that. I believe GPT-4 is 8 mixtural, 8 by, however many parameters. So That means 8 mixture of experts. Llama 3, 70 billion, notably does not use mixture of experts. So Grok, interestingly, has 8 experts, 314 billion parameters. And then Snowflake really stands out here amidst all the other ones. So first of all, 480 billion parameters. And for the number of experts, instead of 8, which is common with the other models, we're seeing 128. So this is new, certainly. So definitely a new sort of approach. So instead of either having one big model, one heavy, slow model, or a mixture of, let's say, 8 smaller models that are a little bit faster, they went to like the very other extreme of having these tiny models, 128 of them. And they're explaining the training efficiency by saying that they use a unique dense MoE hybrid transformer architecture. So you'll notice here also the other models are either dense or they're a mixture of experts. This one is a hybrid of the two, and they're using many but condensed experts with more expert choices. And their deep speed team demonstrated that this approach can be used to significantly improve model quality without increasing compute costs. So they're saying that the improvement of the model quality depended primarily on the number of experts and the total number of parameters in the MoE model and the number of ways in which these experts can be combined together. So this is interesting because we're kind of seeing a somewhat new architecture, like a new approach. And they're saying based on this insight, Arctic is designed to have 480 billion parameters spread across 128 fine-grained experts. This is one trend we started seeing in the last few years. While models get better as we increase them, increase the size, there's also a lot of ways to improve them, make them more efficient as we scale them down. We've been seeing more and more tiny models that are fairly effective at doing the specific thing that they're designed to do. So the key isn't to just get the biggest model possible. If you need it for one specific thing, a tiny nano model or fine-grained experts, as they're calling it here, it can work well. So here they kind of have a chart of the different layout between something like a dense transformer, like what's used in Llama 3, for example, then the mixture of experts, so Mixtral, Grok, etc., as well as their hybrid approach. And keep in mind that this is all open source, weights and code. So if this is a very efficient kind of new approach to doing this, don't be surprised if a lot more other companies start kind of adopting it for their own model. Maybe we'll see Grok 2 or Grok 1.5 using this hybrid approach. And they're noticing that training vanilla mixture of experts architecture, so kind of like this style, right, with a large number of experts is very inefficient, even on the most powerful AI training hardware, because of the high all-to-all communication overhead among experts. I mean, here they're talking about how they can reduce that overhead. That's kind of like what they've found their new approach. And they go deep into how the training curriculum, what they've used, how sort of analogous it is to human life and education, where we train capabilities from simpler to harder, etc. So as promised, they're putting a lot of their research and insights out there for everyone to learn from. And here again, they're showing the enterprise intelligence. So the kind of like that formula that they use for those specific tasks that they believe that enterprise level companies need, right? So coding, database, instruction following, etc. They're comparing it to the active parameters. And again, they're showing that their model is, I mean, you can say one of the best in terms of performance per cost, the performance over cost ratio. And they also talk about their open research insights. They're saying that they want to give back to the community, enrich the collective knowledge, empower others to succeed. And with this release, they're not just unveiling the model, they're also sharing the research insights through a comprehensive cookbook. And this cookbook is designed to expedite the learning process for anyone looking to build world-class MoE models. I gotta say, this seems big. So it's interesting because you can almost see, if we continue on this path of everybody open sourcing their models, their knowledge of compute costs getting cheaper. I mean, this brings to mind Yann. I think everybody says his last name LeCun, but I guess the true native French speakers say Yann LeCun. But he reposted this. And this is the same thing that we've covered in this channel maybe 3 days ago. When Llama 3 got released, And very quickly, it was starting to run on Grok, that new chip that's supposed to provide super fast inference speed. So the outputs that Llama 3 provided, running that on the Grok chip puts that into, hyperspeed. And also it's much less expensive. So when I was doing that video, I was saying how it's going to be a complete game changer. And I showed a few applications. I wish I had this little chart because I think this kind of illustrates what the heck we're talking about here. So GPT-4 to have inference, to have the outputs, you're talking $10 to $30 per 1 million tokens. So 1 million tokens, if we're talking about outputs in English, that's about 750,000 words, roughly, as a rough approximation. If you're running it on Claude 3 Opus, I assume that has to be Claude 3 Opus, right? It's even a little bit more expensive. It's $15 to $75. That big range, basically, it depends if you're talking about inputs or outputs. So reading or writing, basically. And then number 3 is the Llama 3 70 billion open source model that's running on the Grok chip, which again, that can run the cloud. So, you're comparing it to GPT-4 and Claude 3 Opus, etc. But look at that pricing. It's 60 cents, 80 cents per 1 million tokens at lightning fast speeds. I believe Llama 3 70 billion was running at something like 300 tokens per second. The smaller model was doing like 600. A long time ago, we covered this leaked article out of Google. Feels like it's been 5 years or so, but actually hasn't been a year yet. AI time is nuts. But the point of that whole article, and keep in mind, this was so early before we started seeing a lot of these Llama 3s and Groks and Arctics, a lot of these open source projects. Well, I guess this is directly after Llama was, quote unquote, it was leaked. The weights were leaked. So it basically became open source. Some people are saying it was purposefully leaked, right? Like Meta put the weights out there and went, whoops, I hope no one, builds a bunch of cool stuff with this. But they did, right? This article sort of goes over the timeline, right? February 24th, Llama is launched. March 3rd, Llama is, of course, leaked to the public, right? March 12th, so less than 10 days later, right? It's running on Raspberry Pi or running on a toaster, as they say, as he says in the article, right? And they're saying, yeah, it runs too slowly to be practical, but it sets the stage for an onslaught of minification efforts. Onslaught, great word. Then they talk about LoRa, low rank fine tuning. So basically, I always think of it as, if you have like a photo from a camera that's in RAW format, right? It's like gigabytes large, but you're able to take it and create a much lighter version of it, much smaller version of it that looks almost indistinguishable from the original, right? So you kind of scale it down, you don't lose any resolution, but the size gets much smaller. That's kind of how I envision LoRa, right? So you're saying March 13th, suddenly anyone could fine-tune the model to do anything, kicking off a race to the bottom on low-budget fine-tuning projects. So March 13th, so 10 days after the leak, the open source community, which is the global community, basically in some ways catches up to and even gets ahead of these massive companies with their budgets and talent and closed source models. And that was the point of this whole article. They're saying, while we're battling with OpenAI, so this is Google, their leaked memo, their internal memo that was leaked, right? So they're saying, while we're battling with OpenAI, while we've been squabbling with OpenAI, a third faction has been quietly eating our lunch. And that faction is open source. Plainly put, they are lapping us. So again, this was just about a year ago. And this is kind of important to understand because if you're one of these big companies and you want to command these prices, that's the money that you need to keep training new models, keep the research going, to keep paying the bills. What you really don't want to see is a open source version that's available to anyone that's 40 times cheaper and 10 times faster, or I guess 14 times faster. So here's Laura Edelson, Assistant Professor of Computer Science, Northeastern University, Co-Director Cybersecurity for Democracy, formerly Chief Technologist, DOJ Antitrust Division. This was reposted by Yann, and she's saying, I'm so tired of being in rooms where people whisper about the absolute army of big tech-funded people, most of all, but not all, ex-Googlers that have popped up in nearly every quarter in DC where people are working on literally anything to do with AI. So let's talk about it. And look, everything I say here, I'm going to do my best to try to present it without bias, to try to outline what the conversation is so that people can understand it, form their own opinions. I'm not here to try to influence or change your mind, but here's, open source. So open source AI specifically we're talking about, not previous sort of software that we have available. We're talking about neural nets, AI, transformers, etc. So what does open source AI do? What does it provide? Well, number one, it decreases the price for having your own AI software, being able to use it for your business, right? So there's no moat, there's no pricing moat. People are already running Llama 3 on their home computers. If you have a 4090 NVIDIA card, it pretty well runs on that, maybe a little bit slow. The 70 billion, the bigger model that's available, the biggest Llama 3 model that's available right now, maybe it's not super fast, but it works, right? So it's cheaper. The speed of development goes up, again, as that sort of idea of the more people have access to it, right, across the whole world, the more smart people of different skills are potentially able to, cook up something new, figure out how to make it smaller, faster, better in some way, come up with maybe some new architecture, etc. So it increases the speed of development, innovation, etc. Now, of course, the argument can be made that safety decreases. Now, I'm not saying, again, that it's a fact. I'm saying that this is the argument that's being made. And there's very smart people on different sides of that argument. Some say, of course, this decreases AI safety and increases risk because, let's say the bad guys out there in the world are able to take whatever progress, whatever research and apply it to their own nefarious causes, right? That's certainly a very strong possibility. Or, we can probably even say it's a fact that somebody will attempt to use it for something bad, right? That's already we're seeing some telemarketing scam calls using AI voices. More and more government agencies are worried about cybersecurity attacks that are made easier with technologies like this. So yeah, of course, it's going to create some risks. I think that's fact. And there's people that argue against it, Meta. And so one of the proponents of open source technology is, of course, Mark Zuckerberg. He recently was on the Dwarkesh Patel podcast talking about Llama 3, his new release. And he's talking about how responsible open sourcing of these models, open source releases, can almost be better for safety. And he makes the comparison to something like cybersecurity, to where if you figure out the point he makes is, let's say you went back 5 years or 10 years with the modern day understanding of cybersecurity, having that expertise, that knowledge, yeah, of course you'd be able to hack a lot of stuff because you have seen kind of all the vulnerabilities and all the progress that has been made. So it's the fact that people share all the risks, all the vulnerabilities, all the issues that they encounter. It's the sharing of that stuff that helps everyone be more secure, to create better protections, patch various issues, etc. So I think it's safe to say that, when it comes to AI safety and open sourcing these various models, there's people that believe that's the safer course. There's people that believe that that's absolutely not the safe course, and that's really increasing our risk of really bad stuff happening. But the argument that some people are making is that, let's say you're a company that's selling something at $30 a pop, right? So you're making good money, you're selling your product at $30, and somebody provides an open source version of that. And now the customer is able to get that same thing for 60 cents. Well, you're not going to be very happy about that, right? You want to sell that thing for $30. And the problem here is you can't really complain about it because kind of seem like a jerk. Like, hey guys, I can't make as much money because you guys are choosing the cheaper product. That's a bad argument to make. You can't really make that argument effectively. But the easier, more appropriate argument to make would be to say, you know what, actually that product is unsafe. The 60-cent product, that's the product that's going to, kill everyone in the world, and we need to outlaw it. And so that's the conversation that's happening. If we're saying that open source AI is risk, there's going to be some people for whom it is risk. They really believe that, right? So they're sincere about, yes, open source AI is risky. There are other people that are going to say open source is risk, but for them, it just means, less money, more competition. And this is where the conversation gets kind of tricky because it's like, how do you know which is which? And so back to Laura. So she's talking that there's, these people whispering about the absolute army of, big tech people in DC trying to be on anything that is in any way related to AI. And so she's saying, first, this vulnerability exists because we don't properly fund our government anymore. So if some org can fund expertise getting into Congress or agencies, it would be irresponsible to say no because the government can't afford to hire the experts it needs otherwise. These quote-unquote AI experts, none of whom seem to be computer scientists, by the way, they have degrees in philosophy or cosmology or international studies from Oxford, Stanford, or similar, are pushing a few lines of argumentation about AI. But she wants to focus on just one, and that is open weight models are bad. So open source, open weight, etc. This has been going on for a while and has cycled through a few justifications. Previous ones have been a bit silly, like China, Skynet, biotoxins. But the current one, and that is that open source is anti-competitive, isn't quite as ridiculous on its face. So I want to explain why it's dead wrong. The argument goes like this. Free open models from big companies like Meta mean that smaller companies can't compete because they can't afford to not charge, which sounds plausible, but is nonsense when you look at the business model, LLMs, or the history of software. So she posted dates for development of various open weight, open source LLMs going back to 2018. And she's saying open models sure don't seem to be impeding development of either open or closed. This is because open source or open weights have been the norm for a while. It was weird when OpenAI made GPT 3.5 closed with a safety rationale that only makes sense if you forget that they didn't restrict the use case. Misinformation that they claimed was the motivating risk. So why haven't all these open source, open weights models stopped other models in their tracks? Even upstarts like Mistral or Databricks, because the foundational LLM is not the thing that gets sold and never has been. What all these companies sell is helping you use the LLM. Or, you can say in the case of Meta, for example, they might want the functionality themselves for various chatbots, Instagram and Facebook, WhatsApp, etc. And if having open source kind of developing environments allows more developers to be on there improving the product, right? That kind of helps them. They almost have a worldwide talent pool kind of working on their stuff for free. And she continues, that's why Databricks debuted their OpenDBRX before they IPO'd. It's critical to their business success because they make money on all the stuff that gets built on and around the model, especially by them. And even outside of models, open source software has won the argument. Open source means that everyone can innovate faster. So everyone counts on making more money because everyone gets more out of the common ecosystem than they put in. Open source has also won the argument about security. Everyone, good and bad, finds bugs faster. But on balance, this appears to make software more secure because there are more defenders than attackers. Why should you listen to me about this? First, if anyone is not a shill for Meta, it's me. Second, she spent 2022-23 as the chief technologist of the antitrust division of the Department of Justice. So she spent a lot of time thinking about computational antitrust. To be super clear about something, I'm really concerned about AI safety and think much needed to be done to manage the risks. The point in this thread was only that open models don't make these risks worse, and in many cases help mitigate them. And Yann, who reposted this, says, excellent thread. Thank you for stating what should be obvious to everyone, Laura. I just realized I went on like a half an hour long tangent. ADHD is a hell of a drug. Let's get back to Arctic. There's a few more points here that are interesting. And this is their blog post. I'll link it down below if you wanted to read it for yourself. We're just kind of going over the top level ideas here. So again, they're putting out this cookbook. And the reason this is important is, again, this is brand new. This was just announced, released. So right now we're kind of taking everything at face value, assuming that everything is good and will work as advertised, etc. But assuming that it does expedite the learning process for anyone looking to build world-class MoE models using open source software, and combined with the fact that now really small models can be used for specific tasks. And I think this was my original point, is that eventually I think we're going to see people creating these models for like personal use for everyday tasks. Let's say I wanted to create an agent that goes through the various publications online and pulls out the information that I am most interested in. So I don't want to deal with the engagement farming, the outrage politics, etc. I just want certain specific bits of AI news. Is it possible that next year I'll be able to quickly spin up a model, a custom model that I train myself that's significantly better than me at doing that task? That's not going to miss any big stories. That's going to filter out everything that's just noise, etc. And Snowflake, so they're publishing their curriculum on how to compose data. They'll talk about advanced mixture of experts architecture and how to evaluate and compare model quality. Less straightforward than you might think. As I'm wrapping this video up, this got posted, less than a minute ago. It said 41 seconds ago, Greg Brockman of OpenAI, he's saying that the first NVIDIA DGX H200 in the world, hand delivered to OpenAI and dedicated by Jensen, right, the founder of NVIDIA, to advanced AI, computing, and humanity. There it is, Sam Altman. So I always assume they don't post their location in real time. Like, right, if they're all in one room at the same time somewhere at a known location, they're not going to be like live tweeting their conversations or like, we're all here in one building, just from a kind of a security perspective. So I'm trying to make out the date on that one. It looks like April 20th to me. So the picture might have been from a few days ago, but I think that's a tonal machine behind them, one of those cable workout machines that goes on your wall. Well, I can't wait to see what they're cooking up. With that said, my name is Wes. Please subscribe to my channel, Roth, and thank you for watching.